In this lesson, we're going to explore graphing equations, and we're going to start out by talking about the Cartesian plane, which is just the plane that we graph on. Our horizontal axis is the x-axis, and the vertical one is the y. Spend a lot of time talking about planes in geometry, so it is like that one-dimensional flat surface that goes on forever in all directions. And we can graph all of these with x and y. Now remember, when we graph these, each of these lines on the grid represented a number. Typically, we went by ones, 1, 2, 3, etc. But you could go by anything as long as that you label it. So you could go by twos, you could go by fives, whatever number you chose to go by. If you wanted, you could go by 100s, etc. The x and the y axes do not have to be the same unit. So we could go by twos on the x and we could go by 100s on the y's. Typically, you're going to go make your axes whatever will make your data fit. So we're going to make ours go by ones. We're going to graph the points, -3, 4. So in order to graph that, we need to remember, well, where are negatives, where are positives, and what do each of those represent? All of our order pairs are written with the x-coordinate, then the y-coordinate. Negatives are below, so this is a negative value, and to the left, just like that number line that we talked about yesterday. So that means up and to the right, those are all positive axes. So the ordered pair, -3, 4, I'm going to go 1, 2, 3, because it's the x-axis is -3, and 1, 2, 3, 4. This is where 4 is, this is where -3 is, so this is the order pair -3, 4. So our next one, the order pair 2, 0. So I'm going to go 2 on the x and none on the y. So that's the order pair 2, 0. And we also have the order pair 1, 1, 2, 3, 4, -5. Let's talk about the Cartesian plane momentarily when we talk about quadrants. So let's draw our axes. This is the first quadrant. This is the second quadrant. They do go counterclockwise. This is the third. This is the fourth, and we label them with Roman numerals. So if we look at their first order pair, -3, 4, that was in quadrant 2. The order pair 2, 0 is not in either quadrant. It is on the x-axis. And 1, -5 is in the fourth quadrant. Oftentimes we'll want to know the distance between 2 points. So let's draw here. There is a distance formula that we're going to derive here. So let's say this is one of our order pairs. So x1, y1. And our other order pair, x2, y2. And let's say we wanted to know the distance between those 2 points. We can find that by using the distance formula, and we can get the distance formula simply by making this a right triangle. So this horizontal line, I'm going from x1 to x2. So if those are numbers, say 3 and 4, you'd say, oh, they're 1 apart. Or 7 and 100, you'd say they're 93 apart. You are going to always take the second coordinate and divide it by, or subtract the first. Let me rewrite that a little bit bigger. Here we go. So this one I can find by doing x2 minus x1 is the length of this side. Our vertical is the change in the y coordinates. In the y coordinates, I would do the second one, subtract the first. Now, you could do absolute value. We're going to leave this one as is because if you remember the Pythagorean theorem, because this makes a right triangle, I know that a squared plus b squared equals c squared. So my distance squared, which is my c squared, is my a squared plus b squared. So my distance formula would be just the square root of the change in x squared plus the change in y squared. Now you can always do something similar with those to derive these formulas. You can always graph out the points and make your right triangle. So if we complete our example here, we have to find the distance between those 2 points. So if we want, we can just do a little graph. So we'll just say -3, 1 is here. Say 4, 7 is there. Make a triangle. So my x's, I'm going from -3 to 4. So I would walk along 7 spaces. And vertically, I'm going from 1 to 7. So that would be 6. So my distance would be the square root of 7 squared plus 6 squared. I can also find that by using that distance formula. So the distance would be the square root of my second x minus my first squared plus my second y minus my first y. Didn't leave myself enough space, so there we go. Squared, which is 7 squared plus 6 squared. And 7 squared is 49. And 6 squared is 36. So it'd be the square root of 85, which we can round to 3 decimal places if we wanted to. It kind of depends on whatever the directions are. So I'm going to leave that one as square root of 85. So you can always use that distance formula to do your problems. Let me highlight that for you. We can do midpoint formula similar. Midpoint just means the middle. So we're going to use our same 2 points. So x1, y1, x2, y2. So if we're looking for the middle of those two, we would say, oh, it's about there. But we need to know, well, where is that? Now, the middle of the two x's, wouldn't I just find their average, right? Divided by 2. And same with the y's, divided by 2. So that is your formula for your midpoint. So find the midpoint between -3, 1 and 4, 7. I do -3 plus 4, add the x's, divide by 2, add the y's, divide by 2, which is -3 plus 4 is 1 half, and 1 plus 7 divided by 2, so 1 plus 7 is 8, and 4. So the ordered pair in between those two is the ordered pair 1/2, 4. Now to graph equations, we also need to know how to find the intercept. So the x-intercept is when the y is 0. The y-intercept is when the x is 0. These are helpful information. We can also make xy tables. But we're going to focus on intercept. So our first one is y equals 3x minus 1. This is a linear equation. So the x-intercept was when y is 1. So I have 0 equals 3x minus 1. Add 1 to both sides and divide by 3. So that means I have the ordered pair when x is 1/3, y would be 0. My y-intercept is when x is 0. This one is typically easier to find when equations are written explicitly, which means that we have a y equals in most cases. So I have 0, -1. So to graph this one, I simply can graph those two ordered pairs. So 1/3, so that's 1, that's 1, that's 1, that's 1. So 1/3 is about here. 0, -1 is here, so my line will look like this. You can also make an xy table. So if I substitute -1 into the equation for the x, I have -3 minus 1, which is -4. 0 we've already found to be -1. Substitute in 1. 3 times 1 is 3, minus 1 is 2. And you'll also notice that the y values are increasing by that slope of 3. So -4 plus 3 is -1 plus another 3 is the 2. Y equals x squared minus 9. Now we will be spending more time with this in an upcoming section that deals with graphing functions. So you may recognize that it's a quadratic. We're not going to focus too much on that today. We're going to talk about intercepts. So the x-intercept is when y is 0. Add 9 to both sides and take the square root. So I have 3, 0, -3, 0 are couple order pairs. The y-intercept is when x is 0. So I have the order pair 0, -9. So I have 3, 0, -3, 0. This one I'll go by 3's. So I have those ordered pairs. Now I can do it if you want to. You can do the -b over 2a for that vertice. And again, you can also make an ordered pair. But note that those are quadratic, so they should make a nice U that is symmetrical on either side. We're going to talk about symmetry here shortly. Absolute value. I'm going to come back to the x-intercept. Let's do the y-intercept first. Y-intercept is when x is 0. Absolute value, well, 0 minus 4 is -4. Absolute value of 4 is 4, plus 1 is 5. So I have the order pair 0, 5. So we can graph that. If you want, you can use graph paper. It's up to you. The x-intercept is when y is 0. So this one, x-intercept, I come down to -1 equals absolute value of x. We should know absolute value is the distance a number is from 0, and it is never negative. So that means it's not crossing the x-axis. So right now, we know it doesn't go down. Hopefully you remember that absolute values do make V-looking graphs. This one you might want a couple more points. So maybe -1, which would give us a 6. 2, which would also, let's see, 2 would be 2 minus 4 is -2. Absolute value is 2, so I get 3. So we're like, oh, it's not quite making a V yet. So I'm going to skip up. I notice, so if I plug in a 4, I get 0. So 4, 1. Still not coming up. If I do 5, 5 minus 4 is 1, plus 1, I get 2. Oh, and it's coming back up again. And then I can say, oh, well, it's going to look like that. So let's talk about some symmetry. A graph is symmetric with respect to the x-axis if you have x, y, and x negative y. So what that means, say we have, that's our graph. An example of something as symmetric about the x-axis is something that looks like this. They match up on either side. It does not have to be parabolic in shape. It just has to have that feature. So it's the same. If I were to fold along the x-axis, it would match up on either side. The y-axis, it matches up on either side of the y-axis. Again, it does not have to be parabolic, but it should have that feature. And symmetric about the origin. So if I were to fold along both sides, so we'll just go with the easiest one that comes to mind. So if you were to fold on both axes, it would line up. So we want to talk about the type of symmetry. We're going to start with that middle one. These are the same equations, that x squared minus 9. We said the graph, so just copying it from above, it looked like this. And we know to have the order pair 1, -8, and also -1 would be -8. So I have the feature -xy and xy, which when I look up, I don't have quite enough room here, there we go. The one that has that feature is the y-axis. If we look at our 3x minus 1, it'll look like this. So if I pick when x was 1, I got -2, which means to be symmetric with the x-axis, I should also have 1, 2, which I don't have. And then with the origin, I should have the ordered pair -1, 2. So just change the sign of both. So at -1, the order pair is actually -4. So no, it's not symmetric about the origin. The y-axis, I should have the ordered pair -1, -2, and again, none. So this has no symmetry. And then our graph here, looks something like this. Some order pairs on here. I had 4, 1. I'll exaggerate it a little bit. 5, 2, and 3, 2. So picking one of those, so I'll pick the order pair 3, 2. To go with the x axis, I should have the order pair 3, negative 2, which I do not. With the y axis, I should have the order pair negative 3, 2, which I do not. And with the origin, I should have the order pair negative 3, negative 2, which I do not. So this one also has no symmetry. Last thing we want to talk about is an equation of a circle. This is the equation of a circle, and the center is the h and k values, and radius is a value of r. So our equation that we are dealing with, our h is always with x, our y is always with k. So I have the order pair. This is x minus h, so h would be 1. And this is y minus k, so k would be negative 3. And the radius, this is r squared, so the radius, r would be 4. So going over to my graph, I'm going to do 1, 1, 2, 1, negative 3. That's my center. And the radius is 4, so 1, 2, 3, 4. Going off an angle here, it's very difficult to do. So I usually just go from that center up 4 and then go straight across in the horizontal and vertical directions. And then try as best you can to draw your best circle. I do have a circle tool, but that you don't have at home. So there's a lot of information in this section. Make sure you're also using your book as a resource and ask if you have any questions.